combination is a selection of all or parts of a set of objects without regards to the order of selection. So for combination, the order of selection doesn't matter, as opposed to permutation, which has to do with the way in which objects are arranged or ordered. Okay, but to understand combination, which is different from permutation, let us do this example. Okay, so let us say we have three letters, A, B, and C, and these letters may be representations of objects or even people. Okay, all right, so we have these three letters. We have different ways that these letters can be arranged as follows. All right, it could be ABC, ACB, BAC, BCA, CAB, and CBA. Okay, so these are 6 possible ways that we can arrange the three letters. All right, so in our previous video or in our previous lesson, we said that permutation has to do with the arrangement, the different kind of arrangement. So in here we have about 6 permutation, because for this one we have ABC, but for the second we have ACB, so the arrangement is different. So these are 6 different arrangements, so we have 6 different permutations here. Okay, so we say the permutation for 3 objects taking all 3 at the same time will be equals to 6. Okay, but for combination doesn't have to do with the order of selection. So in here we have ABC, and if you look at all of these 6 different arrangements, the 3 letters that are visible in the 3 or these 6 arrangements are just A, B, and C. So in other words, the combination is just the same. Okay, so we say that the combination here for 3 objects taking all 3 at the same time is just 1. Okay, so we say the combination for 3 objects taking all 3 at the same time is equals to 1. So this is the difference between combination and permutation. For permutation, it is concerned with the arrangement, okay, the order of arrangement or the order of selection, but the combination doesn't have to do with the order of selection. So let us see another example. Okay, this one we have about 4 letters, A, B, C, and D. So we are going to take 2 at a time. Okay, so we will have A, B, A, C, A, D, B, A, B, C, B, D, C, A, C, B, C, D, D, A, D, B, D, C. Okay, so these are 12 different arrangements considering the 4 letters, and we select them 2 at a time. All right, so we will have 12 different permutations, because each of these arrangements is different from the other. Okay, so we say that the permutation for 4 objects taking 2 at a time is equals to 12. But the combination, if you see in the first set here, we have AB, and in this other one we have BA. So if you look in here, the 2 letters that are visible in this set are the same 2 letters visible in this set. So in terms of combination, this set and this set are just the same. Okay, so we will cross out 1. So we will consider this to be one set of combination. Okay, for AC we have CA, so it's the same combination. AD and DA is the same combination, and BC and CB the same combination. BD and DB the same, so we cross it out. DC and CD and DC, so we cross one of this out. So we actually have, for combination, we have about 1, 2, 3, 4, 5, 6 different combinations. Okay, because the two letters that are visible in these sets are completely different from one another. So AB is here and AC is here. They are not the same combination. Okay, so in terms of combination, we say if we have 4 letters and taking 2 at a time, we will have 6 combination. Okay, so you clearly see how combination is different from permutation, because permutation has to do with the way in which they are arranged, but combination does not take into consideration the arrangement. That's the simple difference between combination and permutation. So in terms of formula, the combination of n objects taking r at a time is equals to n factorial over r factorial multiplied by n minus r factorial. So looking at this equation, this part of it, n factorial over n minus r factorial is the same as the permutation for n objects taking r at a time. So combination can also be equals to this divided by r factorial. Let us do example problems. Number 1, in how many ways can you select 11 players from a team of 14? Okay, so for this problem, the arrangement, the order of selection doesn't matter. So we say this is a combination problem. If the problem had talked about in a particular selection order, then it means that could be permutation. So, but this is a combination problem. So it means 14C11 is equals to 14 factorial over 11 factorial multiplied by 14 minus 11 factorial. Okay, so what we do here is we simplify in here. So we have 14 factorial or 11 factorial. 14 minus 11 is 3 factorial. So we expand the 14 factorial. We have 14 times 13 times 12 times 11 divided by 11 factorial, and expand the 3 factorial to give you 3 times 2 times 1. So 11 factorial and 11 factorial will go out. Then you are left with 14 times 13 times 12. So you multiply that, you will have 2,184 divided by 6. So if you divide here, you have 364. So 364 is the total group of 11 players that we can get from 14-member team. Let's see another problem. Number 2. Out of 7 consonants and 5 vowels, words of 3 consonants and 2 vowels are formed. A. How many words are formed with different letter combinations? B. How many words in total are formed? So in terms of the solution, we have 7 consonants and 5 vowels. Okay, so the words that are going to be formed will contain 5 letters. Of those 5 letters, 3 are consonant and 2 are vowel letters. So what we're going to do here is we are going to find how many combinations we can get from 7 consonant letters taking 3 at a time. And we also do the same for the vowel letters. Then we then multiply the combination of those 2 to give us the total number of words that will be formed containing different letter combinations. All right, so let us go. We say A. We take the 7 consonant and taking 3 at a time. So we say 7 factorial over 3 factorial into 7 minus 3 factorial. So 7 factorial over 3 factorial, 7 minus 3 is 4. 3 factorial times 4 factorial. So we expand. We have 7 times 6 times 5 times 4 factorial over 3 factorial, which is 3 times 2 times 1 multiplied by 4 factorial. So here 4 factorial and 4 factorial go out. Then we have 3 times 2 times 1 is 6. So we can cross out this entire thing with this 6. Then we have 7 times 5, which is equals to 35. Okay, so we will have 35 different combinations from the 7 consonant letters, taking 3 at a time. Okay, so let us look at the vowels. So we have 5 vowels, 5 vowel letters, then we are going to take 2 at a time. So we have 5 factorial over 2 factorial times 5 minus 2 factorial. 5 factorial over 2 factorial times 3 factorial. So we expand that, we have 5 times 4 times 3 factorial divided by 2 times 1 times 3 factorial. Okay, 2 factorial is 2 times 1. So 3 factorial and 3 factorial will go out. Then you have 2 here. 2 will cancel out with 4, and that will be left with 2 here. So 2 times 5 is 10. So we have 10. All right. So we have 10 different combinations when we have 5 vowel letters and taking 2 at a time. So then, the total number of words having different letter combinations will be the product of these two. So that would be 7C3 times 5C2, which is equals 35 times 10, which is 350. So we have 350 words that will have different letter combinations from the problem here. All right, so let us look at B. So for B, it says how many words in total are formed. Okay, so for this problem, we will have 5 letter words that will be formed because we have 3 consonant and 2 vowels. That's 5 letters. So all of these words that will be formed here contain 5 letters. So we are going to find the permutation for the 5 letters and taking all 5 at a time. All right. Okay, so for B, let us find 5 P5. That is the 5 letters and taking all 5 at the time. So that becomes 5 factorial over 5 minus 5 factorial. So we have 5 times 4 times 3 times 2 times 1 divided by 5 minus 5 is 0, which is 0 factorial. So 5 times 4 times 3 times 1 will give us 120 divided by 0 factorial is 1. So we have 120. So we have 120 different combinations of each of the total number of words that we have here with different letters. So in order to know how many words in total that are being formed, we are going to find the product of the 120 and that of the 350 words that were formed. Okay, so if you do your multiplication here, you will have 42,000. So we have 42,000 words in total that is being formed from this problem. Okay, so that is it. Thank you.